Tonight's video is going to look at density and temperature. We started looking at density in class today with the gummy bear lab, and temperature should be a review for most of us. We should have looked at it at some point in elementary school or lower school, but we'll go over what it means and how to measure it tonight. First up is density. And so density is a measure of how tightly packed together an object is. So this isn't something we measure directly, we calculate it from mass and volume. Alright, so you can write your own notes for this section. So it is a measure of how tightly packed together an object is. So a good way to think about this is think about a brick versus styrofoam. Right? A brick definitely has pretty high density. Right? The molecules in a brick are pretty tightly packed together, whereas styrofoam is much less tightly packed together. It doesn't have anything to do with weight per se. I can have a very tiny piece of a brick that has a very low mass, but it's also very small, so it has a lower density. Whereas styrofoam, even a big piece of styrofoam, has very little mass. So it's basically, we're looking at how tightly packed together an object is. And our units are kind of funky. So the units for density are grams per cubic centimeter, and it's written as a fraction, grams over cubic centimeter. Alright, you can also write it as grams over milliliters, and this should make sense because we know that a cubic centimeter is the same thing as a milliliter, so these two units are the same. What we're literally measuring here is how many grams, how much mass is in each cubic centimeter of volume. So a brick might have a density of 17 grams per cubic centimeter. In every little cubic centimeter, you would have 17 grams of stuff, whereas styrofoam might only be 0.1 grams per cubic centimeter. In every cubic centimeter of styrofoam, you only have 0.1 grams of stuff. So let's look at how to calculate density. All right, what you need to do is you need to know the mass and the volume. And we saw this in our, in our gummy bear lab today. You need to know the mass and volume of an object in order to calculate its density. Alright, so you're going to continue to write your own notes for density. Alright, we measure the mass with a balance and the volume with a graduated cylinder, and then we just divide. We divide the mass by the volume. So mass is under the division sign, volume is outside. So if I measure the mass of a piece of chalk to be 5 grams, the volume to be 2 cubic centimeters, then I know the density is 5 divided by 2. Do my division over here, and I work out that I have 2.5, and then I have to write the entire unit, grams per cubic centimeter. And the cool thing about density is less dense things will float on top of more dense things. This is why wood floats in water. Wood has a density less than water. Same with oil, why oil floats on water. So you can see in this column here, some of these liquids have just food coloring added to them to make them easier to see. But you can see how honey is the densest, it's at the bottom. Corn syrup floats on top of honey. Maple syrup floats on top of that. Then milk, dish soap, water, vegetable oil, rubbing alcohol, and then lamp oil. And you can see there are some solids in here too, because solids have a density, and they're actually just floating in the layer that they're in. So a cherry tomato, for example, has about the same density as dish soap. So it floats in the layer of dish soap, it sinks past the water, but it's less dense than the milk, so it floats on top of that. A dye, like from a set of dice, would float somewhere in the milk / maple syrup layer. So kind of a cool little illustration. So quick density practice calculations. All right, I'll do one. Calculating density. Alright, so some examples. Alright, and we should try and get these examples in our notes. So a brick has a volume of 6 milliliters rather, and a mass of 18 grams. What is the density? So the mass is 18 grams. Volume is 6 milliliters, or I can write that as 6 cubic centimeters. Nope, don't want that. Shift Command plus. Cute. There we go. So my density then, oh dear, that's not what I wanted. So the density of this object is going to be 18 divided by 6, which equals, of course, 3, and I have to put my whole units grams per cubic centimeter. Alright, so on your own, let's do the last two practice problems. So do the other two on your own, and we will check those in class on Monday. Alright, make sure you put the correct units for the density. Alright, we'll finish up quickly looking at temperature. Alright, temperature is pretty straightforward. This is something we should be fairly familiar with. Alright, temperature is a measurement I don't know why that showed up, but I don't want it. Anyway, temperature is a measure of how much heat an object has. So while my notes over here figure out how to unconfuse themselves, we'll get started. Temperature is a measure of how much heat an object has. And so we measure temperature using a thermometer. And so it's a measure of heat an object has, and we measure using a thermometer. Alright, and to measure a thermometer, it's just like using a graduated cylinder. You have to determine how much each division on the thermometer is worth. Usually it's either going to be 1 degree or 2 degrees. And then you read the temperature based on the level of liquid in the thermometer. Alright, we use alcohol thermometers in class. They have some red dye in them to make the alcohol easier to see. We don't have any mercury thermometers, so you won't get mercury poisoning in class, which is good. So for example, this thermometer, we're at 20, there's 1, 2, 3, 4, 5 steps to reach 30, and that's a 10-degree difference. That means each step is worth 2 degrees, which means this temperature is showing a temperature, or thermometer rather, is showing a temperature of 22 degrees Celsius. Alright, some important metric temperatures. We use degree, right, our units are degrees Celsius. And Celsius, you have to know a couple key temperatures, alright? Celsius degrees are defined based on the boiling and freezing points of water. So the freezing point of water is 0 degrees Celsius. So water freezes at 0. Option K gets you the degree sign if you're on a computer, 0 degrees Celsius. Alright, water boils at 100 degrees Celsius. And then another good thing to know is that room temperature, which is about 70 degrees Fahrenheit, is about 21 degrees Celsius. And real quickly, to finish up, we'll talk about what heat is, because it's kind of cool. It's a little different than what we may think of. So heat is a measure of energy in an object. Literally, how much energy do the object's molecules have? So heat is a measure of energy in an object's molecules. Right? More heat means the molecules move faster, which is a higher temperature. Less heat, the molecules move slower, is a lower temperature. And then heat always moves from hot objects, or hotter objects I should say, to cooler objects. So when you walk outside in the winter and you feel cold, your body, which is hotter, is giving heat to the air, which is colder. Right? And so a cool thing that results from this is that there's no such scientific thing as coldness. We can't measure coldness in an object. When we use the word cold, we just mean something has very little heat. So there's no scientific principle of coldness. Coldness is just an absence of heat. Doesn't mean you can't use the word cold to describe something, but just know that when you say, oh, this feels really cold, what you're saying is this thing has very little heat. right? And it's taking heat from my body. So go ahead and make a summary. This is your last set of notes for this unit, and I will see you guys in class on Monday.